To get you started with using mobs quickly, let's first look at the underlying architecture. And the architecture is rather straightforward. It only consists out of 3 elements. So the general working principle of mobs is, first we generate some instances, which are kind of copies of a given geometry that are faster to work with. Then we write a falloff value onto these instances, in our case called mobs_falloff. And lastly, we modify those instances based on this falloff value. That means, for example, if we'd like to translate our instances, an instance with a higher falloff value will be translated further. So let's have a look at this in Houdini and drop down a GeoNode and dive in there. Let's leave the file node for now and drop down a mobs instancer. Next to this node, let's highlight it. And we can see nothing happening there because we haven't specified which objects we'd like to instance. That means which objects we'd like to duplicate or copy. So let's add an instance object and just drag down the file in here. So we can see now the instancer is already set up under the distribution tab to distribute our file in a grid distribution. And there are several subsettings for the grid. We can either distribute it by a fixed number using the distance or with a fixed size, using the step size as an individual distance between instances. Let's go to the fixed number here, and maybe let's set our distance to 1.2 along each axis, and let's have only one layer in y-axis, and increase the x and z counts to say 10 by 10. So these are our initial instances. In order to do something with them, what I want to do first is write a falloff on them to determine how strongly each instance is affected by a given effect. What I like to use most of the time is the mobs shape falloff. So let's drop that down, wire this in here, highlight it. And we can see already we have a visualization of the falloff. And my falloff now is set to be linear. And I can scale this along the z-axis to have a bit of a broader falloff. Also, let's add some noise into it and maybe decrease the noise frequency, like so. Then I can check or uncheck preview falloff to get this color visualization of how big my falloff value is. And in general, the falloff values we're setting should be in the range of 0 to 1. So let's do something with those copies and, for example, go to mobs, modifiers, and these will modify your instances. So for example, let's just drop down a transform modifier, which I tend to use quite often. Wire in our falloff mobs here and highlight this. Not much happening yet. However, if we dial up the y-translate, we can see now that our instances with a falloff value of 1 will be translated all the way up, while the instances with a falloff value of 0 will remain down there. So let's animate this transition by moving this shape falloff here. So what I can either do is just simply grab those handles here and maybe animate this handle's position in this dialog. So let's do that for now. So let's set this to 11 on the first frame, alt-click on this value, go to, say, frame 48, and set this to -11 in this case, alt-click again, and let's hit play to see if that animation works. That is working as expected. Now, this might seem a bit boring, so let's first enable the real-time playback, so it's not running any faster than real-time. So this is now real-time. And again, this might be a bit boring, so let's append a spring modifier. Just leave position checked here, uncheck all the other attributes here, and wire it up below, highlight it, and hit play. And we can see now we've got this wiggly behavior using a physical model of springs. Maybe let's speed up the animation, so in the shape falloff, let's shift click in here, which brings up the animation timeline. And let's move this last keyframe to, say, frame number 24, and also highlight the curve itself and set it to linear. Let's close the timeline again, highlight our spring modifier, and hit play again. Also, let's set our timeline to be only 120 frames long, so we can easily cycle through this animation. And I'd love to have a bit more springiness to it, so let's increase the damping coefficient. So the way a coefficient works is just like the inverse of a weight. That means setting my coefficient to 1 means there will be no damping at all, and setting my coefficient to 0 means the motion will be immediately damped. So let's set it to 0.97 in our case, and hit play again. Maybe increase the mass a bit, like so. So this is the minimal standard setup that you have when dealing with mobs. What you do is you create instances using the mobs instancer, which has a number of distribution options for your instances. After that, you write a falloff value onto those individual instances, which you can modify and set using our different falloff nodes. Then you transform or modify the instances using our modifiers, and maybe add secondary or tertiary or any given number of modifiers to tweak your animation. When you hit tab in the network view, you can go to mobs and you can see those different groups that we created for mobs nodes. And again, what you usually do is first you generate some instances using the generators, then you write some falloff value onto the individual instances, and finally modify those instances using the modifiers.